there. Today we're going to talk about science. More specifically, we're going to talk about how science works. So, science is often used as a noun. It describes a specific thing. But science can also be, although it's not really grammatically correct, used as a verb. And I think that's the more important aspect of science. Science isn't about the thing that we're doing. It's about the process that gets us there. So you'll very often hear me say that I have scienced something or I am going to science something. And so I very much like to use it in that way. So let's talk about this process of science and therefore the scientific method, which is really the entire process of science. All right, so if we're talking about the scientific method and the process of science, then we need to think, hey, how does science start? Where's the beginning of how we make this process work? If we think back to the earliest sorts of scientists, we can really kind of figure this out, because early scientists only had one thing in trying to understand science. They had themselves. And what they had to do is they had to go out there and observe the world around them. They had to experience what there was, and they had to find the information that surrounded them. So where does science start? Science really starts with observation. So we're going to talk about the scientific method. We are going to talk about observation. Maybe I have a little bit of a bias because I come out of a field of ecology where observation really is the starting point to most things. Ecology studies the world outside. And when we go outside, we see things. As soon as we see them, we are then able to say, oh, hey, I see that ant. Or I see these things. I notice this happening. And that's an important part of it. Of course, we're not always fully able to make our own observations of everything. Observation can be a pretty tough thing. And so in many cases, I say observation is important, but also we need to get other people's observation as part of the process. And getting other people's observation typically involves reading about what they've done or scientific research. So research is also a key important part in the process of science. All right, so now that we've observed things and or read about what other people have observed, what are we going to do with it? Well, if it's good science, what the observation should be doing is making you go, I wonder about that. Or if this happens here, why doesn't it happen there? Something along those lines. What actually causes disease? Is there a reason that this person got something and that person didn't? Is there a way that we can understand that? So now you'll notice that all of these things are questions. And so the next step really is indeed asking questions about what we're doing. So we're going to ask a question. But not only do we want to ask a question, if we're making a good observation and using research, we already know something that's out there. So we're not just questioning randomly most of the time. Our questions should be in the form of understanding what we think might happen and therefore creating some kind of prediction. So we come up with a question, but we also need to come up with a prediction. And in science, our educated from our research and observations prediction is called our hypothesis. So many people say a hypothesis is an educated guess. I really don't like the use of the word guess, just because I think it leaves out this idea that we really did actually do work to get here. So we create a statement of hypothesis. This is the thing that is expected to happen, or in some cases, the thing we expect not to happen, just to make it easier to test. And that does, in fact, lead us in the direction of, well, what are you going to do once you have a question or a prediction? Well, you've got to test it out. So, have to run some kind of experiment. Now, experiments vary wildly. They might be something where you can literally test two specific things next to each other, collect some kind of data. It might involve going out into the wilderness and collecting different kinds of data. It might involve human beings and trying to get information off of them. So many different things we could get into, but the key concept with an experiment is, did you go looking for it? Did you make an attempt to change something and or look in places where there were changes to see what exists? Based on your hypothesis, you might have varying kinds of experiments, and then you will collect various kinds of data. So data, of course, is the stuff that comes back from an experiment. And data itself doesn't really tell us much because it can be complex and all over the place. So we still need to do a few more things before we have an understanding of where we're at. Data could be like an observation, but on its own, it's usually just kind of a jumbled mess. So good scientists will not only take their data, but they will do an analysis. They will say, well, what in this data makes sense, and what of it could have been by chance. There's so many things that just happen because we want to make sure that things relate to each other in some way. Or at the very minimum, be able to say in our analysis, here's the data we have, but we don't think it can directly connect to these things. However, it gives us a place to go. And from that analysis, we then draw a somewhat specific conclusion that can help walk us to the next place. So once we have a conclusion, of course, now we can say definitively whether our prediction was correct. Maybe. We could probably say definitively whether our prediction was wrong. If it comes out wrong, then we can say, well, that definitely didn't work. If it supports it, though, it's hard to say. Have we tested everything that's out there? So we have to have a certain amount of validity to it. We have to have a certain amount of analysis to know that. But either way, it provides us with information. And information is important because none of this stops here. A big, important part of what we're doing is that even if I have a conclusion, it doesn't help just me. I need it to help others. And so therefore, I'm going to take my analysis and my conclusion and either use them myself and say, hey, well, what else can I now observe from this to lead me to a new question? Which part of my conclusion makes me go, I wonder if again, or put that information out into the world so somebody else can pick that up and say, I wonder with. And so this is really the process of science. And although you'll find many different versions of the scientific method, I think this one holds up as a good way to understand the process of making things happen. The nice thing about this method is that it's not limited to specific sciences. Anybody can try and use this anywhere. It doesn't limit our types of data. It always brings us to a place where we have to create a conclusion. And it always says start with what you already know and then ask about it. And so it's very useful. I'm only going to add one sort of important thing to this. And the real key important thing is that we have a number of ways that we talk about science. We often say that we have things, for example, such as facts. Or you might hear people talk about theories in science. Both of these are very important concepts that relate to the scientific method in sort of a particular manner. So let's take each of them separately. So if I have a fact, well, hey, what's that going to be? Well, a fact should be something that in some form is evidenced and difficult to dispute. So as part of the scientific method, fact really fits into the experiment data side of things. A fact would be a very clear version of, if this happens, we collected this piece of data, that data tells us what's happening. If that data is then repeatable, we can keep that data and call that a fact. So a fact does have to have multiple pieces of data associated with it. Typically, you can't just say one thing. If you only have one of something, you don't have a fact, you have an anecdote or a personal story or a one-shot. And anecdotes don't make good science. So you need to keep testing over and over again to make these things work. Now, if you do that and you collect many facts, so facts being these supported pieces of data that continuously are supported every time you do a different version of something, you might get to the point where you can say, well, there's so many facts that I can understand this process through this explanation. All of these facts fit into this explanation, and I can use that to explain future things down the road. That is when we get to what we call a scientific theory. Scientific theories are explanations backed by facts which are supported pieces of data for a hypothesis. Once we get to that point, we can explain it, and we can continue to use that theory to test new pieces of data as they come. All of this, of course, is very important because science is constantly changing in some way because the observations are changing. We learn new things, we can improve upon what we know. We don't typically change the entire structural foundation of where we began because some of our data still exists. It's not like the data changes, but we can sometimes change exactly how the data gets explained. And so theories typically take a long time to create and a long time to change, so you'll see that they last for a while. Now, of course, this is different than the way the word is used in many places, but in science, that's how you're going to see it. All right, so that's our process of science, our scientific method, and hopefully enough to help you really get the idea of how you can do science no matter what that science